Hello, everybody. This is our team, and today we're going to be measuring the urban heat island effect on local urban land cover in two cities, Palmdale, California, and Barcelona, Spain. So this is by Callie Samuel and Reza Javadi-Tabrizi. So to first start off, what we wanted to try to find as a team was what type of effect would an urban heat island have on local vegetation? And this was because of our mutual interests. So to come together, we had to discuss what would our research question kind of be, and we both kind of settled on how would land cover either increase or decrease in two different environments, and how would that correlate to the intensity of a nearby heat island? So what we wanted to do was we wanted to capitalize off our study areas. Callie lives in Palmdale, California, and right now I'm in Barcelona, Spain. So how exactly would this either affect our research question and would it cause different results? So what we wanted to do from there was capitalize on our local environment, but then also study it on a citywide scale. And that meant by observing satellite data over the urban heat island effect, and then looking at land cover and vegetation during the summer months on a 4.5 year time scale ranging from 2018 to present. Then we looked at the environment that we were living in, and I found out that for the Köppen climate classification, Callie lives in a semi-arid climate, while I am now in a maritime Mediterranean climate for Spain. As well, one other thing that I found that was kind of interesting was the USDA plant hardiness zone. For Palmdale, it's an 8B, and for Barcelona, it's a 10A. The temperatures to the side of it are when plants can thrive the most. So for a quick method, we were trying to we had a bit of trouble with actually doing some remote sensing, but we were looking for land cover levels and surface temperature values, which could all be found using Landsat 8 data. And first, we had to actually go to the USGS Earth Explorer Geographic Information System. And then from there, we downloaded an application called QGIS, when we had to actually put in a plugin called the semi-automatic classification plugin, and that's SEP. And then we had to pre-process the satellite bands and then perform DOS1 atmospheric corrections and brightness temperatures in Celsius. From there, more specifically, we took the two cities and then we had to obtain Landsat 8 data bands. Specifically, we had one bit of trouble with trying to do land surface temperature because we were looking for band 11. However, there came a new update where only for Landsat 8, there is no band 11. So we only had to rely on STB10 for land surface temperature as it does the calculations automatically. Then a bit more, we had to do raster calculations in order to get the NDVI map. And that meant by doing B5 minus B4 divided by B5 plus B4. And if we took all of those bands and put it into an equation, did a raster calculation, then we would get the NDVI map, and then we could green scale it. Then after that, we had to take the STB10 band and color ramp it with a red, yellow, and blue and invert it in order to get a land surface temperature map. And then from there, we would take both of the maps and try to analyze for any common relationships that we could see. So here's some of the data that we already got. We retrieved the necessary data for a research project practically from USGS Earth Explorer, but then we only use Landsat 8 satellite data on a 4.5 year timescale. And we also collected some globe observations, though not for me because I was moving around a lot and I couldn't really maintain constant observations. To the right, you can actually see Barcelona false color vegetation map for 2022. But then on the bottom, you can also see an LST map, well, actually a land cover map for Barcelona as well. And you can see that near the bottom, and I'm going to touch upon this later, there is an industrial area, and then right next to it, there's a green urban area. So once again, what we were looking for was NDVI, land surface temperature, and then land cover. The credit for the land cover map goes to Lemes Canovas. So here are some of the Barcelona data maps, and this starts off from 2018, but by there I put in a couple of shapes, and with the industrial area that you can see with the land cover map, it's actually extremely hot, and that is because of the materials that are used there don't really do a good job of reflecting heat, and in fact absorb it way more than other materials do, and those are asphalt and concrete that actually absorb heat, and grass and other vegetation cannot do a good job of reflecting it. So right next to it, there's the green urban area that I mentioned earlier. And that scene, it's a darker color. And if it's a darker color, that means it's more vegetation and that it is in fact reflecting more light. And if it's a lighter color, then it means that it's reflecting less light and actually absorbing more heat. So if you have the land surface temperature map, you can see that even though they're right next to each other, there is a vast difference. And one thing about Barcelona is that there's a ton of smaller parks all over the city that are sort of sporadically scattered around, but they don't seem to create that much of a difference on the land surface temperature map, even though there are many of them. It's only with the one exception of the major green urban area right next to the industrial dockyard zone that really makes that much of a difference. Then here's another bit of Barcelona data maps. Then again, you can see that the green urban area pops up a bit more, and then you have some small darker spots that are greener, and those are the smaller parks. And they sometimes show up on the LST map, though not quite as much, and are minimal.
Hi, my name is Kalkidan Samuel, and this is the Palmdale 2018 LST and NDVI map. So basically on the left side is the LST, and the darker surfaces, the darker red, means it's more hot. So the circle, the lighter areas, so the circles, the farmland, they show up to be way lighter than the other areas of Palmdale in 2018, which means that it's way cooler than its surrounding areas, which supports our hypothesis that the cooler areas would have vegetation would have cooler areas. Now, on the right side, you'll see the NDVI for 2018 Palmdale, which is basically showing the vegetation in Palmdale. And like I said, the circled areas are the farmland, which shows in darker green, which means more vegetation. Now, this is a Palmdale 2022 and LST and NDVI, and compared to the 2018, around the farmland it's way less greener, and it's way hotter. So we wanted to correlate the less green with the more heat, which shows to be correct because around the farmland in the left side, the LST is way darker, which means it's way more hotter than it was originally in 2018. And this is just in the span of 4 years. And the right side, as you can see, there's way less green and there's way lighter green. From our personal collected data in Palmdale, California, I found that the sidewalk's average is slightly lower than the dirt by 1.8 degrees Celsius. However, there's a lot of factors to this result, as smoother surfaces tend to be cooler than rougher surfaces since they have more surface area being exposed to light. And the asphalt's average was 62.4 degrees Celsius, the dirt was 57.8, and sidewalk was 56, and the grass was 36.6. However, dirt being considered the natural land cover for the area, this provided adequate heat regulation in the area compared to one of the other main focuses being asphalt. And asphalt being a major contributor to the urban heat island effect, asphalt produced the worst amount of heat regulation in this environment. But from this data, although grass is extremely effective in heat regulation, in this instance, in studying an environment where the natural landscape is sand or dirt, the best option would be left to consider what is natural versus what is not. And basically our conclusion to this is that as our data has shown that natural land cover has a significantly less temperature than contributors to urban heat island, it makes sense to assume that by incorporating them within cities, it could help reduce the effects of urban heat island by producing cooling effects. This can work by constructing these natural land covers to cover some of the contributors to urban heat island that have a lower albedo, an example, urban materials like asphalt. In everyday life, this can be seen in aspects such as increasing or integrating more grass or dirt paths and roads in place of urban material in cities to help decrease temperature over time. But why exactly is it important to incorporate natural land cover in the world? Well, first off, for biodiversity. For example, in forest lands contribute to climate regulation, water quality protection, air quality maintenance, biodiversity conservation, and erosion control, and many more. But also, like our data has shown, it regulates heat, and natural land cover can help decrease surface temperatures, hence trees and vegetation being a good at mitigating heat.
So some positives and difficulties. When we were first entering this research project, it was actually a bit difficult because we had to learn an entirely new software, and that was QGIS. But I find that after going through all of this and going through those difficulties, that it's actually quite fun to use, and the ability to learn it and continue using it, I think, will aid me in future research projects that I wish to do. Then one other thing that I was really interested in were the practical applications. So during the beginning, our mentors kind of threw us in and said, hey, just find a research question that you guys would like to do. And we sort of went running with it. What I meant by practical applications is that we had to find our own research. And even though they helped us along the way, we were rather independent in what we had to do. And even though some prospects would end up in failure and we had to try some different ways, like, for example, we were trying to find electricity usage map for our local cities and compare that to the urban heat island effect, but that didn't really work out because there weren't that many data maps for that. That's one example. While we were given independence in research, it didn't work out, but the fact that we were given it in the first place shows that we had actual practical applications in this project. And then the last thing that I really enjoyed were the soft skills and experiential learning. Again, relating back to kind of throwing us in and then letting us figure out how things work. I learned that after this, that first you have to communicate with your teammate. And even though that may be difficult due to maybe like time zone differences, being able to talk and make sure that you understand each other and to help gets the project done, and it makes sure that everybody is on the same page. Then I guess for difficulties, I mentioned a time zone difference. I'm in Barcelona right now and Cali is in California, but because of that, there is a very small, short period of time that we are able to work with each other where it's either too late for me or too early for her, or the inverse. And we had to schedule ways in order to make sure that even in our busy days that we would be able to talk to each other or communicate at any point in time. Then we had some processing difficulties. I said earlier that there is in fact no band 11 for what we were looking, and I almost went insane because of that, because I was constantly looking for a band 11 that just did not exist. But with the help of Dr. Femi, we managed to find the satellite bands and to get through those processing difficulties in QGIS. Then communications. Communications was sometimes difficult because of the time zone difference, and also we kind of had to go in a sort of tag team manner from period to period in order to make sure that we're doing our work. And then the resolution limit. I was saying that the smaller parks that I was thinking of in Barcelona would maybe make some sort of difference, but I was told that because of a resolution limit, that sometimes those smaller parks maybe not show up in the land surface temperature maps. So even though I was saying that there was a bigger park and it could be seen that it made a bigger difference, but the smaller parks were making a minimal difference, that may be just chalked up to resolution limit not really showing for the land surface temperature maps. For reflections, overall, I thought this was a fantastic experience and I thoroughly enjoyed it. I thought it was educational, quite eye-opening for me because I wish to go into aerospace engineering, and this has been like something that has been a single-minded focus for as long as I can remember. Like when I got into middle school, I had an interview with an aerospace engineer, and then I sort of just thought that would be the path. But after doing this internship, I realized that there is so much more to this field, and that with remote sensing, which I actually quite enjoy, I could be expanding my horizons. And if given the chance to do something similar to this again, I would take it and I would do better.
During my time completing this research, it really amazed me just how much effort is put into observing Earth's condition from the sky. I found it comforting to know how many people are working for the benefit of the planet, and I'm so glad that I was able to work and provide my own data to the field. It was definitely a once in a lifetime experience that I will never forget, that allowed me to consider a lot of different opportunities for my career.
So for an end note, thank you so much to our C's mentors, Dr. Oluwafemi, Dr. Yitong, and Dr. Kachowski, for all the assistance they have given us. And we would like to thank the NASA C's program for allowing us the opportunity to learn, experience, and present in this internship. Thank you so much and have a good day. And to end off, here are some of the references that we have gotten over our research project. Thank you.